Hello, good morning students, and welcome back once again to another video of the class 10th light chapter. In the previous video we finished the revision of the chapter and we finished the chapter itself, and therefore we'll start with the numericals of the lens department and let's get on with it. So the first question today is, a 5 centimeter tall object is placed on the principal axis. If a principal axis of convex lens of focal length 20 centimeters. So we have been given our height of the object and we have been given the focal length of the lens. The distance of the object from the lens is 30 centimeters. So first of all, draw a rough diagram of how it works. This is our convex lens. Let's say this is the principal axis. Okay, and the focal length on both the side, it is given that the focal length is 20 centimeters. So I am writing 20 centimeters over here, f, and therefore 2f over here will be at 40 centimeters. Okay, similarly same thing over here, this is 20 centimeters and over here I am writing 40 centimeters, that is 2f. Now the thing is, the distance of the object from the lens is 30 centimeters. So this is the lens and we know that object is always on the left hand side. So over here 10, then over here we have 30. So the object is placed over here at a distance u, that is 30 centimeters. But because this is on the left hand side, we write minus 30 centimeters. Okay, and this is the focal length, that is plus 20 centimeters. Now because this is a convex lens, we take the focal length on this side, not on this side. However, this is taken as f1, this is taken as 2f1, this is taken as f2, and this is taken as 2f2. So f2 over here is our actual focal length. Now the first question, find the position of the image. So where will the image be? So you can see that the object is between f and 2f, that is between f and c. So the image will be beyond c, that means it should be beyond 2f2. So it should be somewhere more than 40 centimeters. So whatever answer that you are getting, it should be more than 40 centimeters. That is why it will be beyond c. If it is less than 40, then it will be between f and c, or f2 and 2f2, which is not possible, because if the object is between f and 2f, then the image will be beyond 2f. So for this we will apply the lens formula, and lens formula is given by 1 upon f equals 1 upon v minus 1 upon u. Now you need to find v, okay, this over here. So I am writing first of all the values. Focal length is 20 centimeters, so I'll write 1 upon 20. Now because this is focal length in the right hand side, so I will take positive 20. Over here 1 upon v you need to find, minus what is u? U is given as 30 centimeters. The object is placed at a distance of 30 centimeters, so you will write minus 30. Now because this minus and minus, it will become positive over here. So I'll write first of all the values. Focal length is given as plus 20 centimeters. U is given as minus 30 centimeters. So minus and minus becomes plus. So 1 upon 20 equals 1 upon V plus 1 upon 30. You need to find 1 upon V. So you take this on the other hand side, and therefore it becomes minus 1 by 30. So 1 upon 20 minus 1 upon 30 equals 1 upon V. This is what you need to find. Okay. Or I can write 1 upon V equals 1 upon 20 minus 1 upon 30. I just change the left hand side to right hand side. Simple. Take the LCM. LCM will be 60. So you multiply 20 by 3. So over here on the top you multiply 3. Over here 30 by 2. So it becomes 60. So what you have is ultimately 3 minus 2 upon 60, because the LCM is 60. Okay students, 1 upon V. That will give 3 minus 2 is 1 upon 60. Therefore the final value that you get is 1 upon V equals 1 upon 60, or I can write V is equal to 60 centimeters, and because the answer is positive I will write plus 60 centimeters. So like I said, your image distance is plus 60, which is more than 40 centimeters, and therefore the whatever value that you have found is correct. I hope it is clear to you, students. Next is nature of the image. So from this we know that the object is real and inverted. It is the case where the object is beyond C or beyond 2F, and you can write the image is real and inverted. Okay, you can write this statement now as well, or you can first find the size of the image. Okay, first find the size of the image, and for that we have magnification M is equal to V upon U. Remember, this is a lens, so not minus V upon U. You will write plus V upon U. Okay, and then what you will do is substitute the values of the object distance and image distance. So image distance is plus 60 that we just found, and object distance is minus 30 centimeters, so you write minus 30 over here, and you cut the zeros, and 3 2's is 6 and minus sign, so you get minus 2. So the magnification is minus 2, and minus sign indicates that it is inverted. Minus sign indicate it is inverted image, and 2 and magnification is greater than 1, and therefore you can write that the image is enlarged. Image is enlarged. So first you find the size of the image, and final answer you can write as image is enlarged. Image is enlarged, real and inverted. Okay, now you have done the magnification, you have found the actual properties of the image, and now we move on to the third part, that is size of the image. So for that we also have the formula M is equal to H dash upon H. There is no change in this one. Okay, and height you need to find, that is the size of the image. So I will write magnification, now you have, that is minus 2, so I am writing minus 2 over here. H dash is the image height, and H is the height of the object, which is given a 5 centimeter tall object, so I will write 5 over here. Okay, simply cross multiply. Minus 2 into 5 equals H dash, therefore H dash equals minus 10 centimeters. Okay, once again the minus sign indicates that the image is inverted. Okay students, I hope it is clear to you. Observe the whole numerical, pause the video for a second, and if you have any more questions after that, you can ask me. Okay students, so a different numerical for you, and this one is regarding concave lens. So previously this convex lens is a converging lens, and now we are going on to the concave lens, which is a diverging lens. An object of size 7 cm is placed at 27 cm in front of a concave lens of focal length 18 cm. What will be the image distance, image height, and nature? Okay, so just like before, we will draw a rough diagram. Okay, of concave lens. Focus point F over here and 2F. Okay, and the focal length is given as 18 centimeters. Now because this is a concave lens, it will be minus 18 centimeters, and the object is placed at a distance of 27 centimeters. So as we go over here, we get 27 centimeters, let's say somewhere over here. Okay, now because this is a diverging lens, we know that the ray of light will be going like this, and the focus point somewhere over here, and image will be somewhere in between, so it should be less than 18 centimeters. Okay, it should be less than 18 centimeters. That is what we know. So we apply the lens formula, and first of all let's write all the values. So focal length is minus 18 centimeters, u is given as minus 27 centimeters. Lens formula is 1 upon f equals 1 upon v minus 1 upon u. Okay, 1 upon f is 1 upon minus 18 centimeters equals 1 upon v minus 1 upon minus 27 centimeters. That is our u. We need to find v over here. Minus and minus, it becomes plus, so the next step will be minus 1 upon 18 equals 1 upon v plus 1 upon 27, because this minus and minus becomes plus. When we take this plus 1 by 27 on this side, becomes minus, so the next step will be minus 1 upon 18 minus 1 upon 27 equals 1 upon v. Okay, now the LCM is 54 for this two, so the next step will be 18 into 3, so it becomes minus 3 upon 54, and 27 into 2, so it becomes minus 2 upon 54 equals 1 upon v. Now because they both have minus sign, it will be added, and the next step will be minus 3 minus 2 becomes minus 5 upon 54 equals 1 upon v, or I can write v equals minus 54 upon 5. When I solve this, what I get is 5 1 is 5, 0 decimal point, 4 is remaining, so 40, so 5 8 is 40, and what I get is minus 10.8 centimeters. So as you can see, like I said, it should be less than 18 centimeters, and what we are getting v as minus 10.8 centimeters. So it is less than focal length. That means the image will be somewhere over here like this. So what we have done up till now is correct. Now let's move on and find the rest of the values. Find the image height and nature. So for that, once again we'll apply the magnification, and magnification m is given as h dash upon h, and it is given by v upon u, because this is lens, that is why we cannot write minus v upon u. But for finding the image height, we will first require the magnification, and for that magnification is equal to v, that is minus 10.8 upon u, that is minus 27. We will use this, so minus 27, minus minus get cut. Okay, and when you solve this, you will get the answer 4, and because there is one decimal point, you write a decimal point like this. You can solve it slowly manually by 3 as well. 3 9 is 27, 3 3 is 9, one decimal point, 1 is remaining, so 3 6 18. Once again, 3 3 is 9, 3 1 3 decimal point, 3 2 6, and 3 4 is 12, and one decimal point, so 0.4. So you can simplify that way as well. So you get the magnification as plus 0.4, and when you get plus, it means the image is erect. It is not inverted. When you get plus in the magnification, image is erect. But we'll save that for the nature. Okay, first we need to find the height. So let's move on and find the height as well. So magnification m equals h dash upon h. Okay, and magnification is 0.4 over here, image height like this, and now we have 7. Okay, so I'm writing 7 over here as the object height. Cross multiplication, it becomes 0.4 into 7 equals h dash. Therefore h dash equals 7 4s 28 and one decimal point, so you get 2.8 centimeter plus 2.8 centimeters, which means once again that the image is erect. Now because this is a concave lens, divergent lens, image is erect, diminished. Why? Because m is smaller than 1, magnification is smaller than 1, we are getting 0.4 magnification. So image is erect, comma, diminished and virtual. So there you have it, students. This is how you solve the numericals for the concave and convex lenses, and I'll see you all in the next video. If you have any doubts, any comments, please mention them in the comment section down below the video. Okay, till then, have a nice day.